continue to solve quadratic equations with a different method in this lesson, and that method is completing the square. We're used to seeing the quadratic in standard form, and that is ax squared plus bx plus c equals 0. Well, when we're completing the square, you need to put it in a different form. And that form is going to look like this. X squared plus bx equals c. Now look at the difference. I'm actually going to turn the c to a d, a different letter, d. It has no first term in front of the x squared. The bx stays the same. There's no c, and this is not a 0. So what happens is this term gets moved over here, and sometimes this already has a number. Let's say that the c is 5, and this is 10. If we brought this over, it would be a different number. It wouldn't be the same as c. So that's why it's changed to d. So two things you need to notice. No a term, that missing c term, and then the 0 to the right is now a number, most of the time. To complete this method, I have a little phrase for you to say. To complete the square, you're going to think you have it. And that means you take your middle term and divide it by 2. You square it. So whatever you got for your answer here, you're going to square it. And then you add it to both sides. And add it to both sides. And add it to both sides. Okay, that's the end of my phrase. So to start completing the square, you're going to take the middle term, the coefficient of b. You're going to half it, you square it, and you add it to both sides. So that's the end of my phrase. After that, you're going to be able to factor your quadratic, just like we did in chapter 8. And then you're going to be able to solve for x. Okay. Now that we know the process, let's try a problem. Let's try x squared plus 6x equals 7. Okay, now look at this is the form we want. We have no a term, we have no c term, and we have a number to the right, so we're good to go. So you're going to take your b term. This is my b term, and cut it in half. That would be 3. You half it, you square it, and you add it to both sides. So I'm going to take the original equation here, and I'm going to add it to both sides. So here I'm going to add a 9, and to the other side of the equation, I add a 9. Okay. My phrase is over. Now I'm going to factor the left side, so I'm looking at this right here. When we factored it, we thought of 2 factors that multiply to be 9, but add to be 6. So we set up our binomials. So 2 factors that multiply to be 9 is 3 and 3. They also add to be 6. And then on the right side, I'm going to go ahead and add that. Another way to write this, because I have 2 of these quantities, it's the quantity x plus 3 squared. Okay, we learned in the last lesson that we can take the opposite of a square. The opposite of a square is a square root. So a square root gets rid of the square, but I only have 1x plus 3. The square root of 16 has 2 answers. 4 times 4 is 16, and negative 4 times negative 4 is 16. So I have to make sure that I write both answers down. And now I'm going to solve for x. So I'm going to get x by itself by subtracting 3. Now I have 2 problems here. I have a positive 4 minus 3, and I have a negative 4 minus 3. So my answers are 1 and -7. I would like you to try x squared minus 2x equals 3. Push pause and try that now. Okay, so let's do this one together. Start with our phrase. You half it. You half the middle term. So here's my little middle term. It's my b. I'm going to cut it in half. You square it. So -1 times -1 is 1. And you add it to both sides. So I got to add it to the left side and add it to the right side. Now I'm going to factor. I'm on this part right here. I'm going to factor the left side of the equation. Here's the left side right here. I need two numbers that multiply to be 1 but add to be a -2. So I'm thinking -1 plus -1 is a positive 1. And when you add them, it makes a -2. On the right side, I'm going to solve and just get 4. Every time you factor, when you complete the square, you're going to get the same binomials. That's kind of your goal. Rewrite this with a square. So you can take the square root and solve for x. The opposite of a square is a square root. So the square root eliminates the square. The square root of 4 has 2 answers. 2 times 2 is 4, and -2 times -2 is 4. So when I bring the 1 over, I create 2 problems. I have 2 plus 1, and then my other problem is -2 plus 1. So 3 and -1 are my answers. This next problem is going to look a little different. Let's say they give us 2x squared plus 20x minus 8 equals 0. This problem is in standard form. We need to make it look like this in order to complete the square, to use this process. So 2 things have to happen. This 8 needs to be brought to the other side, and I can't have a coefficient in front of the first term. So it doesn't matter the order in which you do this. I think I'm going to divide every term by 2 first. So I get rid of the leading coefficient. So this becomes x squared plus 10x minus 4. Make sure you divide every term by 2. Now I'm going to bring the 4 over. So I get x squared plus 10x equals 4. Now it's in the right form so I can complete the square. I can follow this process. Take your middle term, your b, you half it, you square it, and you add it to both sides. Okay, now I get to factor the left side. I'm looking at this side here. 5 times 5 is 25. 5 plus 5 is 10. I'm going to rewrite this with a square. Okay, the opposite of a square is the square root. The square root eliminates the squared, so I'm left with x plus 5. This time, 29 is not a perfect square. In the past 2 problems, you've had a perfect square here where you're going to be able to do this in your head. At this point, do not find the square root of 29 because then you're going to have to round to a decimal and we don't want that yet. So instead, it's all for x. I'm going to bring 5 to the other side. And my 2 problems become the square root of 29 plus 5 and then the negative square root of 29. Sorry, not plus 5. Let's go back. Oops. This positive square root of 9 minus 5 and then the negative square root of 29 minus 5. Those are the 2 things you're going to put into your calculator. Remember, if you have a scientific calculator like this one, a TI-30, when you push the square root symbol, it opens a set of parentheses. Kind of looks like this. You need to close that parenthesis and then subtract 5. If you don't close that parenthesis, it thinks that 29 minus 5 is under the radical sign, and it shouldn't be that way. Okay, when you put these into your calculator, you're going to want to round to the nearest hundredth. That's what your directions are going to say. So we get 2 answers, and because we're rounding, it's about answer. You can put an equal sign so it means same thing, I guess. Negative 10.39. It doesn't mean the same thing. It's about answer. This is the problem you're trying. 3g squared minus 24g plus 27